Well, this is a typical maths problem paper in which you are asked to find the mutual exclusive events. You are also asked to look at the independent events, and most importantly, you need to know about the conditional events or conditional probability. So let's start with the first question. And here we want to find a pair of mutually exclusive events from A, B, C, and D. A and D share the same events, or D shares the events in A. A and B also share some of the events, but A and C are mutually exclusive because they do not share any of the events. Now there's one more pair of mutually exclusive events, and if you can see event D and also event B. And as you only get 1 mark for this, and it says write down any pair, it means you can write down either the A and the C or either the D and the B. This next question is really fairly simple. You are given that the events in the probability of events happening in B is as 0.04. And what you want to do is find the value of P. Well, let's look at that B events circle. And we know that some of the events, probability events here are 0.24, 0.07, and then there is our unknown. Now, altogether, the events equal to 0.4. So if the events in B, probability of events in B is 0.4, then we can write 0.24 plus 0.07 plus our P. And that should equal to 0.4. So we just got an algebraic situation in here where we have to work out the value of P. And the value of P will be 0.09. Now we have a question about independence. So given that A and B are independent, independency doesn't mean that it's mutually exclusive. The definition of independence is that events have no effect on each other. When you roll a dice or toss a coin, the outcome of one does not affect the other. Therefore, the events are independent. There's a rule here that you need to apply, and you know that you need to apply it because the number of marks you'll get is 2, and all you have to do is find the value of Q. So to get the 2 marks, you need to show what is the rule for event A and B to become independent. So if A and B are to be independent, then the probability of A and B, we need to write this as A intersection B because that is equivalent, is equal to the probability of A multiplied by the probability of B. Now you know that the intersection of A and B is equal to 0.24, which is equal to the probability of A, and we know what the probability of B is because we were given that upstairs, so that's 0.4 in the previous question, it's 0.4. So we know what the probability of PA is by algebraic solution, and this will be 0.6. So if the probability of event A is 0.6, then 0.6 is equal to all the combined probabilities, 0.24 inside A plus 0.16 plus the Q that we would want to find out. And by evaluation, we get that Q is equal to 0.2. Now, the last question is one of conditional probability. And I've just put down here all of the results we got. So probability of A, probability of B, we know what Q is, and we know what P is. We've got to find S and R. And again, you've got a really hefty mark here of 4. And you need to start by addressing this conditional probability. What is the formula for conditional probability? So the probability of B complement given C is written down in the numerator as the probability of B complement intersection C over the probability of C. All right, finding the intersection of B and C would have been really simple because that would have been just P. But finding the intersection of B complement and C, it is worthwhile knowing what that will look like without shading it in. If I have one event and then I have another event, and naturally it must be inside a rectangular box because this is the universal set, then if this was called B and this is called C, the B complement is everything except B, and C of course is C. In that case, the section that you're looking for is the one where is the crescent, I'll call it like a moon crescent of C. Great, let me test you. What would be the intersection of C and B complement? And if you said the C crescent, you would be right. It's hard to write crescent. I might just call it the moon, okay? Moon. So what, again, another question. What would be if I had the probability of A dash intersection B? What would be the intersection? It would be the B moon. It is really quite easy to work this out that way if you can remember it. So now in our case, you can see that this numerator up here is in reality the moon of C, which is in our case R. Okay, so what is the value of P complement C? We're given to be 0.64. So we can write 0.64 is equal to R over P plus R, because P plus R is actually the event C, P plus R. We now substitute the value for P, which is 0.09. Work through algebraically. Just working through this, I am up to 76. 1 minus, oops, that's supposed to be R, will give me 0.36 R. And the value of R in that case, if I use the calculator, I will get 1.6. So now that we know that R is 0.16, to find S, we need to add all of these events together and take them away from 1 because the universal system is equal to 1. So S, therefore, will be equal to 1, take away all of this inside here, which is 0.2 plus 0.24 plus 0.16 plus 0.07 plus 0.09 plus 0.16. And this gave me a value of S being 0.08. I did this on the calculator and I hope that I got that right. But you can let me know if I got this wrong in the comments. In the comments, you can also let me know if there are some papers that you want me to calculate for you and write it out here. I'll be happy to do that. And please remember to give me a like and also subscribe.